We will try to understand about different deployment strategies we have. One is based on user traffic, and second is based on batch of servers. Now we'll deep down into each of the category. When I say based on user traffic, um, it is basically referring to three categories. One is blue-green deployment, second is canary deployment, and third is linear deployment. Now, what I mean by each of these, when we say blue-green deployment, we are actually referring to identical set of infra, and we are switching traffic at once. Like in one go, we are shifting our entire user traffic to the new model. And when I say blue-green deployment, what I mean by blue-green is shifting traffic at once to a new fleet of servers, and after monitoring for a specific period of time, then we terminate our old set of instances or a set of fleet, we can say. When I say about canary deployment is when we are shifting our traffic in a small portion and monitoring it for a certain period of time, and then we are shifting the rest of the traffic and deleting the old fleet of instances. So this is how we are shifting traffic in two steps. Now there is a third, that is linear deployment. Linear deployment means we are shifting our user traffic in more than two steps. What I mean by this is, let's say 20% in one go, then incrementally adding 20% each time until it hit 100% user traffic, and that shifting of the traffic is basically decided based on the baking time which we have set in for each subset of user traffic monitoring. And now there is one deployment guardrail that is done based on batch of instances or batch of servers, we can say. It is like when, like in one step, we are deploying two servers and we are checking, monitoring our new model for a specific period of time. If there is no accuracy drop, or we can say no health issues, then we are incrementing our next um, fixed number of servers until we reach the total count of servers which are serving for a stable model. So this is how we ensure that our um, user is not experiencing issues in the production and catching the issues early in the production before it impacts the entire business. Okay, we will try to understand the deployment guardrails for updating models in production. So first, we will understand what is the benefit of deployment guardrail. One is deployment safety while updating production environment. That is, like it will not cause unplanned downtime that can impact our business, can increase model latency, and customer can experience error rates while accessing our newer model. Second is fully managed deployment. What I mean by fully managed is it is monitoring our newly deployed model, and it is doing automatic rollback mechanism for us. Along with this fully managed feature, it is also giving visibility so that we can track the progress of our deployment. And it also have event bridge that is actually sending an event to the lambda function, which is doing automatic rollback based on the trigger from event bridge. Or same goes for even sending an alert by sending the trigger to SNS service. The deployment guardrail that we have seen in like the type of endpoints we have in SageMaker. One is asynchronous inference. Asynchronous inference means when the user request is around 1 TB, so it requires a near real time latency for our model to predict when we use this type of endpoint. And second, we have real time inference. Real time inference, I mean persistent request serving, one request at a time, then prediction. This is heavily used for lightweight models, and asynchronous inference is used for um, heavy models where the payload is in GB. Then this is the benefits which we get from these production deployment guardrails. Then we have the types of deployment we have. So one type is based on shifting percentage of traffic, and second is based on shifting count of instance. What I mean by these two categories, we'll understand now. Based on traffic shifting, like the percentage of traffic that needs to be shifted. So there could be one approach that all the traffic is shifted at once. Second is the traffic is shifted in small portion, and then after testing the small portion, the traffic is shifted to the rest of um, a user. And this is monitor, and this CloudWatch helping us to decide whether this new model needs to be rolled back to the stable version or the model is performing good in the production. Then comes linear traffic shifting. What I mean by linear traffic shifting is that we are shifting our traffic in more than two steps. Let's say first we are shifting 20%, then based on CloudWatch matrix, we are deciding whether to move next 20% or next 20% until it hits 100% user traffic. Then we have rolling deployment. What I mean by rolling deployment is based on the count of instance we are deciding to move onto new fixed set of server after each iteration of waiting for baking period of time. And then after this validation, we're moving to next batch of instances. Then we have update endpoint and create endpoint. What I mean by this is the deployment guardrail which we are preferring for our project, that we need to update in the configuration, and then that configuration will create an endpoint based on the uh, changes we have configured in our endpoint. So this is how we shift our traffic based on user or based on infra availability.